Thank you for joining again for our session. And we are going to continue with our question today, which is question 41. Okay. Now, question 41, your answer is A apple. How to get A apple as your answer? For this, I need to show you. Because some of you might have problem. Now, when we are talking about oxidation number, you see, of the sulfur, S2O32 negative. I'm using the red. We assume that the oxidation number of sulfur equals to X. So 2X plus 3 times of negative 2 equals to the overall charge, which is negative 2. 2X minus 6 equals to negative 4. So 2X will be equals to positive 4 and X will be equals to positive 2. I hope you are okay with this. Okay. Now for number 42. For number 42, the following equation represents the combustion of propane in excess oxygen. This is the equation, and given to us is 48 centimeter cube of propane is completely burnt. Now, what is the volume of carbon dioxide gas produced? And our answer will be D donkey. Okay, for this answer, D donkey. Anyone has problem on this? Anyone?
Me, teacher.
Okay, so I will discuss. Good. When I say anyone, faster you tell you have problem. Now see, this is the equation. The propane is burnt completely. For the 8 centimeter cube of propane is burnt completely. I'm going to use the whiteboard so that you can see clearly. Now, you are having the C3. You're having the C3H8 plus 5 mole of oxygen gas, giving you 3 mole of carbon dioxide gas and 4 mole of water. Okay. In the question, it was told that this is 48 centimeter cube. And we want to know what is the volume of carbon dioxide gas produced. And when we are calculating volume, actually we get it as decimeter cube. Now, why is it? I'm going to show you now. First of all, we have to calculate the number of mole, okay, of the C3H8. Given to us is 48 centimeter cube. And we have to change to decimeter cube. How many decimeter cube is 48 centimeter cube? You have to take this to divide by 1000 and you are getting your answer as 0.048 decimeter cube. I hope you are with me. 0.048 decimeter cube and divided by the molar volume given to us, which is 24 decimeter cube per mole. Okay, I show you now why do we have to change it to decimeter cube. Can you see 1 decimeter cube, 1 decimeter cube? You cancel it off. Someone please tell me what is the number of mole that you obtain? Anyone? Hello. Your answer should be 0.0.
Oh.
How many zero here?
0.002.
0.002 mole. Okay, now look at this. The ratio of the C3H8 is to the carbon dioxide. From the equation 1:3. So when you are getting this 0.002, it will be producing 0.006 mole. And from here, we are going to go on to our step 3, which is the volume of carbon dioxide gas. Take the number of mole, multiply with the molar volume. Can you see again? The mole and the per mole cancel off and you get your final answer in the unit of decimeter cube. Repeat now. Why I said that it is a 3 steps calculation? Step 1, step 2, and step 3. Okay, I hope you are okay with this. Any problem? Any more? No more?
Sure.
Yes.
Sure, I just did 48 times 3. I get the same answer.
48 times 3. Where's your step 1?
Why did you do 48 times 3?
Because so got 1 mole, then got 3 more carbon dioxide, so 48 times 3 like.
Okay, now if this is a paper 2, you take 48 times 3. Is it necessary you are going to get this? If this is not the gas, this is a solid substance, you won't get. If this is solid substance, you have to still multiply with the molar volume, molar mass. Okay, that's why always don't go for shortcut. Follow the 3 steps. If you go for shortcut and you are too used to it, at last, you will be very careless in your exam. Okay, now we continue with our next question, which is now we are at question 43. Hilmi has an iron spoon. He wants to make the spoon to be more beautiful and durable, to give his friends as a present. Now, what is the best way to do? We have already studied many times where we are going to talk about electroplating. Therefore, your answer is CCAT. Okay, now question from me. If I want to electroplate this iron spoon with copper, where should I put the iron spoon? The anode or the cathode?
Anode.
Anode, everyone agree? I want to put it at the anode, the iron spoon. Who agree? Show me your light. Someone said that we are going to put iron spoon as the anode. If you agree, you show a light. Or no one agree with you.
Cathode.
Yes, you should be putting it as the cathode. If you put at the anode, what is the process that happens at the anode? Oxidation occurs. So the iron spoon will become iron 2 ion. Okay. Now I want to electroplate it with copper. So suggest a suitable electrolyte. Who can suggest a suitable electrolyte? Someone?
Copper 2 nitrate.
Copper 2 nitrate, correct. Okay. So what will happen? The half equation that occur when it is at the, if you are electroplating the iron spoon with the copper, we are talking about this electroplate iron spoon with copper. What will happen is the copper will become the anode. Okay. Can you write the half equation that happened at the anode? Now, the half equation for the process that happened at the anode will be the copper undergoes oxidation to form copper 2 ion. Always remember from atom it becomes ions, then you get this to occur. Okay, 2 positive, 2 electrons. That's why the copper electrode will become thinner. So now at the iron spoon, what will happen? This is at the cathode now, where the iron spoon is there. What is the half equation at the cathode? Okay, now the copper 2 ion will gain electrons to form the copper atom. Therefore, the iron spoon will have a layer of brown coating on it. Okay, so this is about our electroplating. Please know about it, important. Now, next, 44. Your answer should be B-boy. Anyone has problem on this? Answer B-boy. Anyone have problem? No, this is again 3 steps calculation. Yes.
No, it's 3 steps calculation.
Are you okay?
Yeah, okay.
Okay, now next part, number 45. It shows the number of proton and electrons of element J, L, P, and Q. Now, which of the correct formula and type of bond is formed? If we are given this, the number of proton and the number of electrons, we are now going to start writing the electron arrangement. Take the number of electrons. Can you see 8 and 8, 11 and 11, 12 and 12, 17 and 17? That means these are all neutral atoms. Okay? Therefore, the electron arrangement for J will be 2, 6. For L will be 2, 8, 1, 2, 8, 2, and 2, 8, 7. Now, which one is correct? Look at option A. Option A given to us. Option A given to us is L2J. Okay. The L is a metal. The J is a non-metal. So the L will form, for the L, the L will form L positive. The J will form J2 negative. Take the number 1 cross it, take the number 2 cross it. So you are getting L2J. And it is ionic bond. That's why your answer is A apple. Now what about this? LJ2 covalent, wrong. About P and Q. P is this 282. The Q is 287. So for the P, it is forming actually P2 positive ion. And for the Q, it is actually forming Q negative. When you take the number 2 cross it, the number 1 cross it, you are getting PQ2, not P2Q. And it is an ionic compound, is correct, ionic compound. Okay? Can follow up? Now we continue for the next one, where we are now talking about question 46. Question 46, your answer is D, donkey. Anyone has problem? No problem, huh? Okay, 47, your answer is A, apple. Any problem? No problem. And please, I remind you, you have to know how to explain why the ammonia solution can prevent coagulation to occur. And on the other hand, why the ethanoic acid can cause coagulation to occur. Okay. Now, number 48, your answer will be B-boy. I hope you have no problem. And for 49, your answer is B-boy as well. Any problem with this?
Teacher, 50
Yes.
is boy.
Which one?
Number 50.
Sorry, 49 is B-boy. Number 50 is
okay.
C-cat.
Okay.
Okay, I repeat. 48 B-boy, 49 B-boy, and 50. The last question, C-cat. Any problem?
48.
48. Okay, now let's look at 48. Now question 48 says that the W reacts with X to form an ionic compound with the formula WX2. Keywords are ionic compound, WX2. Electron arrangement of atom X is 287. Now, meaning to say, when the X is 287, meaning the X form X negative. Okay. And the W, let's say I am representing it using an M positive. You get your final answer as this. So when you take the number M cross it, you take the number 1 cross it, you get this. Agree? Therefore, the M is actually 2. And the W will actually charge 2 positive. How to charge the 2? How to get the charge 2 positive? It should this atom should have 2 valence electrons. That's why your answer is B1. I hope I have answered your question. Any more problem before we move on? No problem, huh? Okay, thank you very much. So you please have a count later how many objective questions that you get correct. Okay, now we are now already finished discussion on the paper 1 for Pahang set 1. Now we are going to move on to our paper 2, which is on the essay question. Please get ready with your answer. We are now going to discuss on question 9. Okay, this is the question. I hope you are still with me. Now the diagram 9 shows a newspaper cutting about injury case by explosion of hydrogen balloons that are exposed to source of flame nearby. Now we continue. State the reason why the balloon explode and name the suitable gas to replace the hydrogen gas. And you need to explain your answer. Now, can anyone tell me why the balloon explode? And what is the keyword of the question actually? Did you see? They say that it is exposed to the source of flame nearby. When it is exposed to the source of flame nearby, that means what there is. What there is? That means there is heat. Okay? And we know that the hydrogen gas is flammable. Therefore, your point 1. The reason why the balloon explodes, number 1, point 1, hydrogen gas is flammable. Okay? Now, you are going to name a suitable gas. You don't want to use hydrogen gas anymore. So what is suitable? Your answer can be helium. Please take note, it is named, so you have to spell it out. Helium is suitable to replace. What is the reason? Reason number 1, helium is lighter. And everyone knows that helium is chemically inert. So with that, you make up the 4 points. I repeat, helium is used to substitute the hydrogen gas. Reason, helium is lighter. Please no writing light because light does not compare. Lighter than hydrogen gas. Or you can say the helium gas is lighter than the air. Next one, the helium gas is chemically inert or chemically unreactive. Okay, now next part. It has been a long time that we have not discussed about question related to iron, the reaction between iron and halogen. So now here is the question. Iron reacts with chlorine and bromine gases. Can you see the reactants here? Now we want to look from the observation. What's the difference that you get from the observation? Okay. Now I need you to take note about the words here. Can you see? Ignites rapidly. Compared here, glows bright and moderately fast. Now, when we are using the word ignite rapidly with a bright flame, and the glowing, that means which one is more reactive? Which is more reactive towards the chlorine gas? The answer, which is more reactive towards the iron, the chlorine gas or the bromine gas? The answer is chlorine. Okay, and we know that in our group 17, the chlorine is higher than the bromine. The fluorine, the chlorine, the bromine, and the iodine. Today we are talking about these two. So we know that as going down group 17, this is group 17, going down. The reactivity decreases. Okay, so this reaction tells you the reactivity decreases. And I wish you to look at the brown solid. Can you see the brown solid? Okay, now why is it brown? We are going to explain based on the chemical equation. Now when I have iron to react with the chlorine gas, we are actually getting iron 3 chloride. Why? Because the oxidation number of the iron will change from 0 to positive 3. This is the reason why you get a brown solid. And I'm going to balance up the equation. I'm going to put a 2 here, put a 3, and a 2 here. Now, same goes to the bromine. When iron...
Teacher, why is it not iron 2 chloride?
Oh, this is based on the reaction. The chemical properties is that it will form iron 3 substances. It will form a compound with iron 3 ion. Okay? Now, iron reacts with the bromine gas. You are going to get iron 3 bromide. And you are going to balance up the equation. A 2, a 3, and a 2. Okay? That's why you are getting the brown solid again. Okay, now we continue. Next part. Write chemical equation for reaction 2. Can you see reaction 2? Just now we have written. And compare the reactivity of both reactions. Can you see the word compare? Compare. So which is more reactive? Of course, your answer will be chlorine is more reactive than bromine. I repeat, the chlorine is more reactive than bromine. Or you can say that the reactivity of reaction 1 is higher than reaction 2. I repeat, the reactivity of reaction 1 is higher than reaction 2. Okay, what's the reason? Because they ask you to explain, what's the reason why the reactivity of reaction 1 is higher than reaction 2? We are going to relate what we have studied previously. What will be our first sentence, someone? We want to explain about the reactivity when going down the group. What the first sentence we are going to talk about what?
Atomic size.
Okay, atomic size of who? Of course, in this case, we are going to compare about the chlorine and the bromine. So the atomic size of chlorine is larger or smaller?
Smaller.
Yes, the atomic size of chlorine is smaller than bromine. Next, what we are talking about after the atomic size?
Force of attraction.
Jichen, what is the next that we are talking about after the atomic size? When the size is getting bigger, what happened to the distance between the nucleus and the valence electrons? The distance become Vaishnavi? Valencia?
The
Yes,
distance
good. Valencia, the distance become further. Okay, now we continue. When the distance become further, then what happened to the force of attraction? We are going to tell the force of attraction of the nucleus towards the electrons in chlorine atom is weaker or stronger. Which is stronger?
Chlorine.
Yes, in chlorine atom is stronger. And we are going to talk about the tendency of the atom to attract electron. So the tendency of chlorine atom to attract electrons is higher compared to the bromine atom. Remember, you have to use the word atom because this is question related to chapter 4. Now, next part. The metals are placed in the group 1, lithium, sodium, and potassium. By using all the metals given, you are going to describe an experiment to investigate the reactivity of metal with water. And you are going to include observations of the experiment and any one of the equation. Can you see any one? That means, let's say you want to use the lithium, so you put lithium to react with the water. At the beginning of the lesson just now, when we are discussing the objective question, I've already written for you. So now I'm not going to repeat. Now the reactivity of metal with water. So what is the first step that you are going to do? What is the first step? Someone respond, please.
Cut a small pieces of metal.
Okay, Kachun, can you please repeat?
Cut a small pieces of metal.
Okay, cut a small piece of metal. Which metal are we going to start with? In this case, we are going to do one by one. You cannot be putting all together in the same basin of water. So let's say I start with lithium. So cut a small piece of lithium using what? Using a knife and forceps. Okay. Then what do you do after you have cut the small piece? Keyword, small piece. On the surface of this lithium, we know that it is dipped into the paraffin oil. It is immersed in paraffin oil. So we have to dry the paraffin oil on the surface of the lithium using a piece of filter paper. Okay. Now, what is next? after that? We want to put it to react with the water. What apparatus that we are going to use? Dashish?
Throw.
You throw or you place?
Place.
Yes, place the piece of lithium into a basin which is half filled with water. Okay, with a basin or the water trough which is half filled with water. Then what do? You are going to record the observations. Let's say just now you have mentioned 4 steps. So now the next step, you are going to repeat step 1 to 4 by replacing the lithium with sodium and potassium. Okay, this is your procedure. So now for your observation, what are you going to write? All of them actually will move slowly, will move on the surface of the water. And we know that in the group 1, this lithium, in group 1, the lithium is at the highest location. Lithium, sodium, potassium. And we are talking about group 1, therefore, when going down group 1, the reactivity increases. So the potassium is the most reactive. Okay, so you can say that for the observation, you are going to make a table for your observation. Let's say this is your table. Again, same thing. So this part, you can put the metal. This part you can put the metal here. Then this part you can put observation. Okay. Now what are the metals that you use? Number 1, you put lithium. Number 2, you are putting the sodium. Number 3, you are putting the potassium. Okay. Now, you want to compare the observation for these 3 metals. So what are you going to write here for your comparison? You are going to tell that we know that this reactivity is increasing. So you can say that the lithium move slowly on the surface of water. Okay. Then after that, what are you going to? Lithium move slowly on the surface of water. Okay. Now, next, for the sodium, you are going to use the similar word, but then you change the slowly. For the lithium, you have done. For the sodium, the slowly, this part, the slowly, you can say that it moves rapidly. Then for the potassium, you change. You can put very rapidly. This is how you differentiate the observation. And of course, moving and burns with a pop sound, that one is all correct, all the same. For this pop sound is all the same. And some books, they will say that the sodium move rapidly and randomly can on the surface of water. I hope you can understand what I mean. The purpose of putting this observation is to differentiate the reactivity of these metals. Okay? Any problem until here? Any problem
Sure.
until here? Yes?
You can explain about B number 9B about the chemical equation.
Which one? The chemical equation here.
Yeah, 9B.
Part B. This one, this one is it?
Yeah.
Okay, set 1 or set 2?
Set 2.
Set 2. Okay, the chemical equation that you are going to obtain, you are actually getting the iron, from here iron react with bromine. Whenever you have reaction of the iron with the halogen, iron with halogen, the products being formed will be actually the iron 3 halide. This is for sure. So what are you going to substitute is the halide. So from bromine, you are going to get bromide. Therefore, you are getting the iron 3 bromide. How do you get the FeBr3? It is Fe3 positive, Br negative 1. You take the number 3 cross it, take the number 1 cross it. Then you get this. As to balance up the equation, you want to make this bromine to be 6, so you multiply by 3. So the iron, you multiply by a 2. Any problem until now? And we have mentioned previously, anything with the iron 3 ion, it is for sure brown in color. Is it okay until here?
Yes.
Okay, thank you. Any more problem? Any more problem? No problem, Can, Okay. I hope you are okay until here. Any problem? No, Okay. If you have no problem, then this is the end of our lesson today. And what will be your homework?
Teacher,
Yes.
I just want to ask a teacher, because the last time we did one of the sets, there was this question where you have to differentiate between iron 2 and iron 3, and teacher used sodium hydroxide.
Yes.
But then in my school, they emphasized us to use potassium hexacyanophrate and potassium thiocyanate.
Okay.
So I'm not sure.
What reaction is that they are talking about?
Chemical test, teacher.
Okay. Now for chemical test, it is not wrong for you to use sodium hydroxide solution, but you have to tell until you are putting it in until it is in excess. Same goes to the for the ammonia solution you can use. Other than this, you can use potassium hexacyanophrate 2 solution. You can use potassium hexacyanophrate 3 solution. And for the presence of the iron 3 ion, you can use the potassium thiocyanate solution. And the 3 solutions that I mentioned, the potassium thiocyanate, the potassium hexacyanophrate 2, and the potassium hexacyanophrate 3 is actually one of the chemicals that we can use to confirm the presence of iron 2 ion or iron 3 ion. Okay? No problem.
Okay, teacher, thank you.
Okay. Now, any more problem? No, Now I want to know, have you completed the essay question 10? Have you? If you have not, then it will be your homework today. Essay question 10. And if you have time, please proceed to the paper 3. I repeat, essay question 10 and Pahang set 1, paper 3. Pahang 2019 set 1, paper 3. Any problem? Any? Okay, if you have no problem, then we are going to see each other tomorrow at the same time. Okay, thank you very much for joining, and please stay safe, stay at home. Thank you. Take care.
Thank you, teacher.
Okay,
Thank
bye.
you, teacher.
Bye.